Firstly, let me show you what is Green Theorem. Green Theorem is especially for closed loop line integral. So, first we take the general equation for the line integral, which is integral of c p dx plus q dy. Because this closed loop, automatically we will obtain a region that is D. So, from the line integral equation, we get the double integral of D dq over dx minus dp over dy dx dy. Before that, we have to acknowledge that there are two situations in this theorem. It is important because they are different in terms of order. If the curve run counterclockwise, it yields to positive rotation, while if the curve run clockwise, it yields to negative rotation. So what is the difference? Okay, let's look on formula for positive rotation. We use this formula instead, and for negative rotation.
So in this section, I gonna talk about what is magnetic field and applying Green's theorem in magnetic field across a circle. So a magnetic field is a force field that is created by a magnet or a moving electric charge. It exerts a force on other magnets or moving electric charge within the field, attracting or repelling them. If the charge is positive and the magnetic field points into the page, the charge will follow counterclockwise direction, while a negative charge will follow a clockwise direction. So in our group, we gonna use counterclockwise direction in Green's theorem in magnetic field. So in question 1, use Green theorem to evaluate where C is shown below.
We will present about the question 1, which is we need to use Green theorem that related with our course, which is electronic and computer, that we need to evaluate grad negative y dy plus x dx where C, which is circle, is shown below. That question we use to fulfill for the task for question 3. Okay, this solution that we already done, which is inside the circle is our region, which is radius region, that we use the circle formula, which is x squared plus y squared equal to radius squared. That value given on this question is 16, which is r squared. Then we obtain the radius equal to 4 by square root the 16. Okay, the circle show that the arrow of a magnetic is in counterclockwise. So we use this formula to obtain the value. So we use formula, which is double integration in Green theorem. Okay, first thing first, we differentiate the g by respect to x. So dg dx we obtain 1, and we differentiate f respect to y, and then we obtain negative 1, and both of the values we substitute into the Green theorem formula, and then we get double integral r to double integral to dA, and then we arrange the formula to with our calculation. So first we integrate the r, and then we get answer for r integration, and then we integrate the theta, then we get 32 pi.
Another application that use Green's theorem is signal of triangle wave.
Triangle wave is a non-sinusoidal waveform that often used in sound synthesis, like a musical instrument. It is also description as a Fourier series and as a line spectrum. In calculus, the triangle wave over xy plane is known as a piecewise smooth curve because the curve can be extended to curve form. So based on the graph, the arrow flow to the right or x-axis. It is the direction of charge flowing. The line with the coordinate of curve 1 is joined to curve 2 and end with the coordinate curve 3 with the direction of clockwise. So related to the Green's theorem, the region inside triangle is closed piecewise smooth curve oriented clockwise that needs to integrate.
Now I'm going to explain the question 2. Applying Green's theorem for flux across a triangle, let S be the triangle with vertical 0, 0, 1, 0 and 0, 3 oriented clockwise. From this question, this is our solution that we discussed. First, let be the region enclosed by S. Let Px equals 2x and let Qy equal to 1. So, let Px plus Qy equals 2x plus 1. This is the formula for the Green theorem after we convert from Px plus Qy to the Green theorem. We get negative double integral 2x plus 1. Notice that the top edge of the triangle is the line y equals to negative 3x plus 3. Therefore, in the literated double integral, the y value run from y equals 0 to y equals to negative 3x plus 3. This is the formula for Green theorem. First we do the first integrate to negative 3x plus 3 and we got negative 6x squared plus 3x plus 3. After that we do the second integrate. We get the integrals negative 2x power 3 plus 3x power 2 divided by 2 plus 3x. So we continue with replacing the x with 1 and 0. Negative 2 multiplied by 1 power 3 plus 3 multiplied 1 power 2 divided by 2 plus 3 multiplied by 1, then subtract with 0 and the answer is negative 5/2.